Welcome back to Science for Sleep, a place where questions are allowed to linger, where curiosity doesn't demand answers right away, and where science unfolds gently, one idea at a time. As you settle in, let your breathing slow. There's nothing you need to understand all at once, nothing you need to solve. Tonight is about something vast, something that stretches beyond everyday intuition. Tonight, we're asking a question that lives at the edge of modern physics. If a fifth dimension exists, what measurable proof could we actually find? To begin, we need to soften a common misunderstanding. Dimensions are not places. They are directions. Ways in which movement, change, or measurement can occur. You already live in multiple dimensions. 3 of space, and 1 of time. Up and down, left and right, forward and back, and always forward through time. These are not optional. They define reality as you experience it. A fifth dimension, if it exists, would not be somewhere you travel to. It would be something reality already uses, but hides. A direction not easily perceived. A degree of freedom beyond ordinary experience. Physicists didn't invent extra dimensions for fun. They emerged from necessity. When equations describing the universe began to fail, adding dimensions made them work. This is not speculation. It is mathematics responding to inconsistency. One of the earliest hints came from attempts to unify forces. Gravity behaves differently from the other fundamental forces. It is incredibly weak, yet it governs cosmic structure. Physicists noticed something strange. If gravity could spread into extra dimensions, it would appear weaker in the dimensions we observe, like sound dispersing into open space. This idea offered an explanation, not proof, but possibility. Modern theories like string theory suggest the universe may have many more dimensions, curled up, compact, and hidden at scales far smaller than atoms. These dimensions would not be visible. They would influence behavior indirectly, subtly, quietly. So how do you test something you can't see? You look for effects, not presence, but consequence. One possible measurable signal involves gravity itself. At very small distances, gravity should follow precise mathematical behavior. If extra dimensions exist, gravity may deviate slightly from predictions. Experiments have attempted to measure gravity at submillimeter scales. So far, results match known physics, but precision improves every year. A tiny deviation could be revolutionary. Another possible signal involves particle collisions. In powerful accelerators, energy is converted into mass and motion. If extra dimensions exist, energy could disappear into them. Not vanish, just move somewhere inaccessible. Physicists look for missing energy signatures, patterns that don't add up. So far, nothing conclusive. But absence is not disproof. It is limitation. Cosmology offers another path. The early universe was extreme. Dense, hot, violent. If extra dimensions influenced expansion, they could leave imprints in cosmic background radiation. Subtle asymmetries, unexpected correlations. Scientists search for these patterns carefully, slowly. There is also the idea of dimensional leakage. If higher dimensions exist, they might allow particles or forces to move in unusual ways. Shortcuts through space-time. Anomalies in quantum behavior. Unexplained correlations. These ideas border speculation, but they are grounded in equations. Then there are more controversial proposals. That consciousness itself may interact with higher dimensions. That the brain, as a complex system, might be sensitive to structures beyond ordinary space-time. There is no experimental evidence for this, but the idea persists, because consciousness already behaves strangely. Non-local correlations, emergent properties, subjective experience. Science does not yet fully understand it. Conspiracy theories often fill these gaps. Claims of hidden experiments, suppressed discoveries, secret confirmations of extra dimensions. There is no credible evidence for these claims. Science thrives on publication, not secrecy. Extraordinary discoveries demand exposure. Still, the fascination remains, because extra dimensions offer something profound, a reminder that reality may be deeper than appearance, that what we experience is not the whole. As you listen now, notice how the mind responds to vast ideas, not with tension, but with quiet wonder. You don't need to picture a fifth dimension. You only need to allow the possibility that reality has more structure than perception reveals. To understand what proof of a fifth dimension would actually look like, we need to be precise about what science accepts as evidence. Physics does not rely on intuition. It relies on prediction. If a theory proposes something real, it must change what we measure. Not dramatically at first, often subtly. Quiet discrepancies, numbers that refuse to line up. This is why extra dimensions are so difficult to confirm. They are designed, mathematically, to hide, curled so tightly that direct access is impossible. Yet even hidden dimensions must influence the universe. They cannot exist without consequence. One of the clearest measurable paths involves gravity behaving incorrectly. In everyday experience, gravity follows an inverse square law. Double the distance, the force weakens by 4. This relationship is precise, reliable, tested, but only down to a certain scale. Below that scale, experiments become incredibly difficult. If extra dimensions exist, gravity may begin to spread into them. Not suddenly, gradually. At very small distances, gravity would weaken faster than expected. This deviation would be measurable, not visually, but mathematically. Experiments have pushed closer and closer to this threshold. Tiny torsion balances, vacuum chambers, extreme isolation from vibration. So far, gravity behaves as predicted. But the absence of evidence at one scale does not eliminate deeper scales. Physics is patient. Another possible measurable signal lies in particle lifetimes. Particles decay in predictable ways. Their lifespans are governed by probabilities. If extra dimensions exist, some particles could decay faster or slower than expected. Energy might leak. Momentum might appear unbalanced. These effects would not announce themselves. They would whisper. This is why massive particle detectors run for years. They do not wait for fireworks. They wait for statistics. Millions of events. Billions of collisions. Looking for patterns that refuse to vanish. There is also the idea of resonances. If extra dimensions exist, particles might vibrate in them. Just as a guitar string produces harmonics. These resonances would show up as new particles, or unusual energy signatures. This is one of the primary predictions of string-inspired models. So far, no confirmed resonances. But parameter space remains vast. Cosmology offers a different kind of measurement. The universe is expanding. Not uniformly. Not calmly. Accelerated expansion suggests something unknown. Dark energy. Dark matter. Some theories propose that extra dimensions influence this behavior. If energy can flow between dimensions, cosmic expansion could be affected. Subtly. Over billions of years. Measurements of distant galaxies, supernovae, and background radiation are compared against models. Yet, no confirmation. But no closure either. Time itself complicates the picture. Time behaves like a dimension, but not like space. You move freely through space. You move only forward through time. What? Some physicists propose that time may be constrained by higher dimensions. That what we experience as time is a projection. A shadow of something more complex. This idea remains theoretical. But it highlights an important point. Even the dimensions we know are not fully understood. This opens the door to philosophical interpretations. Not conspiratorial, but conceptual. What if the universe is layered? What if dimensions are not places but rules? Ways reality organizes change. If so, proof may never look like discovery. It may look like inevitability. The moment equations can no longer work without extra structure. Conspiracy theories often misinterpret this uncertainty. They imagine hidden laboratories confirming extra dimensions secretly. But science does not function that way. Discoveries of this magnitude cannot be hidden. They demand collaboration, verification, repetition. Silence is not evidence. Still, curiosity persists, because the idea of a fifth dimension is not about escape. It is about completeness, about whether our picture of reality is finished or still unfolding. As your breathing slows now, notice how the mind relaxes when answers are not demanded. Science does not rush. It waits for clarity. If a fifth dimension were confirmed tomorrow, it would not simply add another line to textbooks. It would quietly rearrange how reality itself is understood. Because dimensions are not decorations. They are constraints. They determine what can happen and what cannot. Causality, the simple idea that causes come before effects, depends on dimensional structure. In the space and time, events unfold in sequence. One moment leads to the next. But in higher dimensional mathematics, this sequence can become less rigid. Paths can exist that reconnect points in unexpected ways, not violating cause and effect, but re-expressing it. This is why physicists are careful. Extra dimensions do not automatically mean time travel or paradox. They mean additional degrees of freedom. More ways for systems to evolve. More room for consistency, not less. One proposal suggests that what we experience as randomness in quantum mechanics could emerge from deterministic behavior in higher dimensions. From our perspective, outcomes appear probabilistic. But from a higher dimensional viewpoint, they may be fixed. Hidden variables, not hidden by secrecy, but by dimensional limitation. This idea is speculative, but mathematically coherent. Another consequence involves locality. In 3 dimensions, objects influence nearby objects. Distance matters. But in higher dimensional spaces, points that appear far apart may be closer through unseen directions. This could explain quantum entanglement, not as faster-than-light communication, but as proximity we cannot perceive. Again, this is not proven, but it reframes the mystery. What would measurable proof look like in this context? It would not be a doorway opening. It would be correlations changing, predictions sharpening, experiments suddenly aligning where they once diverged. Proof in physics often arrives as relief, equations that finally stop resisting. This has happened before. The prediction of antimatter, the bending of light by gravity, the expansion of the universe. Each was controversial. Each felt speculative, until measurements forced acceptance. The fifth dimension may follow the same path. Not dramatic, inevitable. Some physicists believe proof will come indirectly, not through direct detection, but through the failure of existing models. When no amount of refinement explains observations, when something extra is required, dimensions may be added not because they are desired, but because they are unavoidable. This is how science progresses, not by chasing wonder, but by confronting inconsistency. As for conspiracies, claims that governments already know the truth, they misunderstand the nature of modern physics. Discoveries of this scale require international verification. They cannot remain isolated. No single experiment would be enough. Proof emerges through convergence, not revelation. Still, the fascination with hidden dimensions speaks to something human. A sense that reality may be deeper than appearance. That what we see is not the whole. Science does not deny this. It simply asks for patience. As you rest now, consider how comfortable uncertainty can be. Not everything needs resolution. Some questions are valuable precisely because they remain open. If a fifth dimension exists, it is not waiting to be found. It is already here, quietly shaping behavior, subtly influencing outcomes, whether we detect it or not. And if it does not exist, then our search will still teach us something essential. That reality is coherent, that mystery has boundaries, that understanding grows through limits as much as expansion. So we return gently to the question that started this journey. If a fifth dimension exists, what measurable proof could we actually find? Not belief, not intuition, not interpretation. Proof. In science, proof does not arrive as certainty. It arrives as constraint. When observations force explanations to narrow, when alternatives quietly disappear, when only one structure remains capable of holding everything together. For a fifth dimension, proof would likely take one of three forms. The first would be persistent deviation, a measurable effect that cannot be eliminated by better instruments, refined models, or hidden errors. Gravity behaving incorrectly at small scales. Particles losing energy in ways no known interaction explains. Correlations that refuse to fade with repetition. Not a single anomaly, a pattern. The second would be predictive necessity. A model that includes a fifth dimension would begin making correct predictions where others fail. Not poetic explanations, accurate ones. Numbers that land precisely where experiments point. This is how relativity triumphed, how quantum mechanics endured, not by elegance, but by accuracy. The third would be convergence. Independent experiments, different fields, separate methods, all pointing toward the same extra structure. Cosmology, particle physics, gravitational measurement. When unrelated evidence aligns, speculation becomes explanation. What would not count as proof? Personal experience, altered states, subjective intuition, single unexplained events. Science does not reject these because they are meaningless, but because they cannot be isolated from interpretation. Dimensions must be shared realities, not private ones. This does not diminish human experience. It simply draws a boundary. Science explains structure. Meaning belongs elsewhere. And this is where many conspiracies misunderstand the process. They assume knowledge is hidden. But in reality, it is unfinished. Extra dimensions remain unconfirmed not because they are suppressed, but because nature has not yet required them. Still, the search itself has value. Even if no fifth dimension is ever found, the effort refines our understanding. Instruments become more precise. Models become more honest. Assumptions are tested. Science advances regardless of outcome. There is also something quietly humbling here. The universe does not owe us answers. It offers consistency. We learn by aligning with it, not demanding it conform to imagination. As you lie here now, notice how this thought settles. Reality may be deeper than perception, or it may be exactly as deep as it needs to be. Either way, understanding grows. The fifth dimension, if it exists, will not announce itself. It will reveal itself only when ignoring it becomes impossible. And until then, curiosity is enough. There is nothing left to chase tonight. No edge to reach. No hidden door to open. Only the calm recognition that knowledge unfolds slowly, and that not knowing is not failure. It is part of the process. Let your breathing soften. Let the ideas dissolve gently. Sleep does not need answers, only rest. Good night, crescent moon.